As the sun rose over the USS George H.W. Bush aircraft carrier on May the 14th, 2013, history was about to be made. The sleek, tailless X-47B stood on the flight deck, poised for its first ever autonomous catapult launch. The engineers and crew watched with anticipation as the unmanned aircraft soared into the sky, marking a new era in naval aviation and signaling the advent of autonomous combat aircraft. Military aviation experts worldwide have acknowledged the significance of the X-47B's successful demonstrations as proof of concept for the future of autonomous combat aircraft. This handsome drone even earned the Navy call sign, the Salty Dog. This is Military Mechanics, and in this episode, we will talk about the X-47B Unmanned Combat Air Vehicle. The X-47B is a revolutionary unmanned combat air vehicle, or UCAV, that was developed as part of the US Navy's Joint Unmanned Combat Air Systems, or JUCAS, program. JUCAS was established in 2003 as a joint effort between the US Department of Defense and the US defense industry to advance the development of UCAVs. The program aimed to develop a new generation of autonomous unmanned aircraft that could perform a variety of missions, including intelligence, surveillance, reconnaissance, and strike operations. The development of the X-47B began in 2007 when the US Navy awarded contracts to two aerospace companies, Northrop Grumman and Boeing, to develop prototypes of UCAVs. The X-47B was developed by Northrop Grumman and was designed to be a stealthy, tailless aircraft that could operate autonomously or be remotely piloted. Though development costs were quite significant, reaching nearly $1.5 billion by 2015, that's almost $2 billion on 2023, the program meshed well with evolving Navy requirements. The X-47B was unique in that it was the first UCAV to be developed specifically for use by the US Navy, and it was designed to operate from aircraft carriers. The X-47B's flight tests began in 2011 and lasted for slightly more than 4 years. During this time, it demonstrated the capacity to carry out a full range of shipboard and non-combat aerial operations, such as deck handling, launch and recovery, integration with manned aircraft operations, and in-air refueling from a manned tanker, all important firsts for autonomous UAVs. With a length of 38 feet 2 inches and a wingspan of 62.1 feet extended and 30.9 feet folded, the X-47B was capable of reaching speeds of Mach 0.9 plus, or high subsonic, and cruising at an altitude of 42,000 feet. It was powered by a single Pratt & Whitney F100 220U turbofan engine, and had a maximum takeoff weight of 44,567 pounds. It had a range of 2,400 miles. The UCAS is equipped with electro-optics, or EO, infrared, IR, synthetic aperture radar, SAR, inverse SAR, ground-moving target indicator, or GMTI, electronic support measures, or ESM, and maritime moving target indicator, MMTI, sensors. It has 2 internal weapons bays capable of carrying up to 4,500 pounds of ordnance, including Joint Direct Attack Munitions, or JDAMs, and Small Diameter Bombs, SDBs. While the X-47B is not the first unmanned naval drone, it set itself apart through its unprecedented combination of stealth and autonomy. Utilizing a combination of GPS, inertial navigation systems, and machine vision technology, the X-47B was able to accurately navigate, take off, and land on a carrier without human intervention. This breakthrough demonstrated the enormous potential of unmanned systems in naval operations. The X-47B was designed with stealth in mind, featuring a low radar cross-section and a highly aerodynamic shape to reduce its visibility to radar. The X-47B's stealthy design was achieved through the use of radar-absorbent materials, a tailless design, and the careful shaping of its aircraft surfaces. Additionally, the X-47B was designed to carry weapons internally, further reducing its radar cross-section and making it more difficult to detect by enemy radar systems. One of the X-47B's most notable achievements was its successful autonomous aerial refueling test in 2015. By demonstrating this capability, the X-47B further extended its operational range and endurance, marking a critical advancement in the development of autonomous aircraft technology. Although only 2 X-47B aircraft were produced, primarily as technology demonstrators, their impact on military aviation has been immense. The success of the X-47B has laid the foundation for future unmanned combat air systems, such as the US Navy's MQ-25 Stingray unmanned tanker aircraft program.